Hi everyone, my name is Wayne. Thank you for having me in Korea, and thank you for inventing Korean barbecue. It's very delicious. And today I just want to talk about Unity 5, and in particular all the awesome audio features that we're going to be putting into Unity 5, which is really awesome. So about me, I work on the core team at Unity as a developer. I work in the Copenhagen office in Denmark. I moved there from Australia about 2 years ago or so. And before then I originally worked at Fmod, which I don't know if you guys know, this is an audio middleware engine out there. And I work on all the awesome stuff at Unity and do some fun stuff there, so I'm loving it. So I just want to talk quickly about the history of audio in Unity. Audio has not received much love in the past, and the features haven't really been pushed that hard. There's been really limited in-editor development of features. Most of the stuff is either only the audio clip or the audio source that you can really manipulate in the editor. But there were aspects of the audio system that had some power. You could implement DSP callback filters in script. You could create custom audio clips, but it was really hard to find. It was really obscure, and so most of the audio features required scripting. All the advanced stuff that you guys needed to do, like music systems or audio managers, you had to either write yourself or you had to get them from the asset store. And some of the functionality in Unity that you probably want to do was completely missing, like submixing. Always the audio source played directly into the audio listener, and you couldn't categorize and group sounds beforehand. So we're taking a new direction at Unity. We're making a big push for all the audio features. We're rewriting a lot of the asset pipeline completely to achieve this, to create a new foundation of audio asset pipeline. And we're rewriting a lot of the audio management, like the sound management within Unity, and we're really optimizing those sort of features. And part of our change is we're also really pushing more UI-focused tools that really empower the sound engineers, because we want to address a lot of the gaps that are basically there in the current audio system. So today I want to talk about the audio system rewrite and the features that we're doing there, and the new audio mixer. So with the asset pipeline rewrite, we began by separating the importing of audio files into a completely separate process. This reduces memory footprint on Unity. Now you can import arbitrarily sized audio clips. It doesn't increase the memory footprint of Unity at all. And it also eliminates the chances of corrupted audio files bringing down Unity, because Unity is only loading the actual processed data. And we've also implemented a new optimized codec support. We've removed MP3 compression target, because MP3 has a lot of issues, I believe, and it really isn't a nice format for games. The format we've replaced it with is called Vorbis Tremor. It's a really, really optimized version of Vorbis. And we've also added a new 80 PCM compression option. So I just want to go through those different compression options and show you what it's all about. So with PCM, it's just raw data. There's no compression, obviously. But there's no decode costs, and it's really suitable for really short sounds like footsteps or gunshots or whatever. There's 80 PCM. It has a constant compression ratio. It has really cheap decodes, but it's not really suitable for all sounds. It's got some compression artifacts, but it's really good for like natural, noisy, low frequency sounds. So yeah. And we have this new Vorbis target, which is obviously the maximum compression you can get. It's kind of the heaviest of all three, obviously, on decode costs, but it's suitable for any sounds. It has great consistency across all sound types and frequencies, and yeah, you can stream a music file from disk if you want, or decode a short step sound into memory. It's really good. The benefits of this compression type: it's much more performant than MP3, and obviously straight Ogg Vorbis. It has really low memory footprint, and there's no looping artifacts, which is inherent with MP3. So I just want to give you a quick example of the different targets that we support in Unity now, and I can just show you I've got a sweep tone here, which is just basically sweeping from low frequency to high frequency. And I'm not going to play it because it's really annoying, but you can see that the straight PCM version has a really crisp envelope. You can see that with the 80 PCM target, there's some noise around the low frequencies, and it just starts becoming even increasingly worse at high frequencies. So again, it's not for all types of sounds, but it's very cheap to decode. And the Vorbis compression, there's basically no noise. There's a little bit of noise at very low frequencies. So, and I've got a memory stats graph here, just showing you the comparison between the new Vorbis compression type and the old Ogg Vorbis memory usage for the different load types. You can see that it's much better. So, audio clip. We've also added this new load type called dynamic loading. Previously, you've only ever been able to load either decompress on load, compress in memory, or streaming. And now we have this new dynamic loading compression target. And what that does is allows you to actually delay the loading of the audio data when you load the scene. So the data itself is not loaded into memory or anything like that, or it's not creating any stream handles. And the data can be loaded by you later during gameplay any way you want. You can load it into memory, you can stream it. And yeah, audio clips become this really lightweight structure that essentially allows you to create your own loading strategies, which is really, really powerful. And you can also choose to load sounds either blocking, so Unity will stop while the sound is loading, or non-blocking. So you can actually ask Unity to load in the background, and you can then ask it, are you ready to play? Are you ready to play? And I've just got a quick example here of how it will work. You've got an API called dynamic load, and yeah, the different options there, and an example of how you want to load it. Very simple. So we also really optimized the way we handle channels in Unity. We now free the resources up as soon as we're finished playing with them. So we put them back on the stack so they can be reused quite quickly. And we've also fixed, I guess, the streaming support. So you can now do proper streaming from asset bundles, and the editor actually does proper streaming, which replicates the behavior of the actual built game. Beforehand, the editor always loaded the the sound directly into memory. We have better handling of large files, obviously, because of this, all these reasons. And the audio clip information can be queried without actually loading the data. So you can ask the audio clip, its length, its frequency, while it hasn't actually, the data hasn't actually been loaded. And we've really improved profiling. We have a lot more information in the profiler now. And we also have multi-edit audio clip, which a lot of you guys have been asking for a while. So now you can select a bunch of audio clips and edit them all together. Cool. So now I just want to talk about the audio mixer. This is our first big push for new features within Unity. It's kind of like our first offering to you guys in terms of a really UI-centric and powerful tool that you can create dynamic audio in Unity with. Yeah, so I guess some of you guys are actually probably asking, like, what is an audio mixer? What does it do for me? And it essentially allows you to create really complex mixing and routing, mastering of your game. You can take all of the sounds in your soundscape and have them mixed through the audio mixer, and allows you to really master the whole game mix during edit and during play mode as well. You can add DSP effects like echo, reverbs, anywhere in the signal chain now. And yeah, it allows you to create categories of sounds, apply effects, attenuation, and all of those things right in the editor while you're actually creating the game itself. And you can really create this really fine-grained mix, mastering, while you're actually playing the game. So you can imagine you're playing the game in the editor, and you're mastering the mix right there while you're doing it. So it's really cool. So what an audio mixer is actually a new type of asset that you can create. It's got a really extensive authoring tool, a new window in Unity. It's modeled on existing digital audio workstation designs, like if any of you guys have used Pro Tools or Logic, those sorts of things. So if you're familiar with those tools, you should be familiar with how things will work here. And you don't just have to have one audio mixer per project. You can have multiple audio mixers loaded at once. You can have audio mixers routing into other audio mixers. Yeah, you can do some pretty powerful stuff. So I'll just give a quick example. I've already created an audio mixer here, which shows you just some basic audio groups. These guys, or the audio groups, are represented here as these strips. And if I click on an audio group, I can show that in the inspector, we have all the effect parameters and stuff showing directly within the inspector itself. And yeah, it's got the ability to obviously monitor the sounds playing through the game as we play. So I'll show you that quickly. I'll do a little bit of mastering of the sounds in this game here. So you see we can't really hear the footsteps. So what I'll do is I'll boost them. So that sounds a little bit better. And I can play music. So it's a little bit loud, so I'm going to reduce the level of the music and sort of get this going. Cool. So that's basically what a mixer is. But I'll go through the concepts a little bit more. So I want to talk about the concept of routing and what routing is. I touched on it before. Basically, routing allows you to create really complex hierarchies of categories of sounds, apply effects and volume adjustments and all those sorts of things. And that hierarchy mixes together and comes together until it reaches the master group of every audio mixer. And from that master group, you can choose to route the audio signal into another audio listener, the audio listener itself, or another audio group of another audio mixer. And I'll give an example of why that can be powerful when I do my example. And I've just got a little diagram here showing the audio source. It's routing into the audio group of one particular audio mixer. That's coming together to the master group. And then you either have the choice of routing it into another audio group of another audio mixer or the audio listener. And now I just want to talk about how audio sources sort of connect to all of this. So audio sources can be routed to any group, as I said before. But before then, all of the 3D attenuation and sort of distance-based or like 3D-based calculations are done before that's actually going into the audio mixer. So this happens at the audio source, and the attenuated signal is then routed into any of the mixers that you want. So I'm going to give an example, and in my example I'm going to show that we have this world, and there's nothing, you can't hear anything, there's no ambient sounds. So what I'm going to do is create a little bit of an ambient situation here. So I'm going to go into here, and just simply I've got some ambient noises. So some basic sounds you would hear in nature. So before I would just drag these sounds into the hierarchy, and I can go into play mode as if I would. But we want to actually mix the game. We want to mix those sounds so that they sound a little bit better. So it's really simple. You would just go into your project browser, create a new audio mixer. I'm going to call this one Ambience. And I'm going to add a group for this particular example, and I'm going to add a group for each type of sounds. Birds. And frogs. Now, all you have to do is go into the audio listeners and simply route those guys to the appropriate bus. So I wanted to put the crickets in the crickets bus, audio group. I want to route the birds to the birds group. And the frogs to the frogs group. And now I can start mixing this situation. Okay, so that sounds a little bit better. I've done a quick mix, and just to finish off the example, I'm going to actually route the output of this audio mixer into the other mixer that I had, and I'm going to show why that's cool in the coming examples. So I'm going to actually route this to the aux-in audio group of the other audio mixer. And if I go into play mode now and I switch to the other mixer, I should be able to see the audio there. Cool. So, now we can talk about effects and what effects are and what they mean for your game. So effects are things like echo and reverb, those sorts of things that you want to actually apply to your sounds in your game dynamically. And these can be dropped anywhere within the hierarchy, within any of these audio groups that I was showing you. You can modify effect parameters in the inspector directly, as you can see in the example. There's an echo effect and a reverb effect. And you can also allow wet mixing to tune the amount of how much of the signal should go through the effect and be modified and changed by the effect, and how much should go through a dry channel around the effect. So you can really, for each individual effect, you can really decide how much you want this effect to kind of take part. And you can stack these effects, obviously, in each audio group, as you can see here. And initially, Unity ships with a whole bunch of effects that you can choose from, optimized for all of the platforms. But, yeah. So I've got an example here of an audio group and how this works with effects. So obviously you've got the signal, the audio signal coming in. You apply some DSP effect, maybe an echo, like I was saying before, and then that signal is then passed on to the next effect. Then we apply some attenuation, maybe apply another effect. We take some metering information, which is shown in the strip that you saw before, and then we pass that signal off onto the next group. So you can start seeing how audio groups work, how DSP effects sit in this audio group, and how the signal is really handled. We also provide the ability to do native plugin effects now. And what a native plugin effect is it allows you guys, or third-party guys, to develop your own custom DSP. And this can be compiled into a plugin, and then this will be actually directly visible within the effect menu. So if I show you, I can add a whole bunch of effects. This is the inbuilt effects here, and these are a bunch of demo effects, demo plugins that we will ship with our example projects, showing you different types of effects. You can define parameters to these native effects, expose those guys to Unity, and those parameters will obviously be tweakable in the inspector, like all the other effects that are built into Unity. And you can define custom UI for each plugin. So instead of just having a simple interface here, you can define and draw whatever you want in that little area that's more relevant to your effect. And I'll give an example of that in a minute. And so, yeah, developers like you guys or third-party DSP companies can create custom DSPs that you can then obviously download off the asset store, buy directly, or anything like that. So, I'm going to give you an example of how all this works. I have an example here of the callback interface that you have to implement. It's just a bunch of callbacks that you have to create, and when it's compiled in, all of this stuff will be detected by Unity, and we'll reach into these callbacks. As an example here, I have a roboticizing effect, so make a sound like a robot. And we also have an example of custom UI, so custom C# script that you would write to implement your UI. And this is for a loudness meter that you would want to use when you're sort of mastering your game. And I'll show those two effects in the actual game itself here. So I guess we can just jump into play mode and start adding effects, and I'll show you how you can tweak those effects and just play around with the mix in that way. I don't know why there's any music playing, but I'm going to play my own music. Oops. I also have an example of like a multi-band EQ with a custom UI. So we just have like a custom UI that you can draw curves with for your multi-band EQ. So you can start seeing that we can really create weird and wonderful different mixes really quickly in this new feature. I'll give you a quick example of the loudness meter that I showed you before in code, and it's just a simple. I can get it to work. Oops. So it's basically just monitoring the loudness, metering the loudness of the whole mix across a period of time. So cool. So that's an example of effects and plugin effects. Now, I want to talk about snapshots. We have this ability to create snapshots in the audio mixer as well. And what snapshots are, they capture the state of all the parameters. The effect parameters, the volume, pitch, ducking settings, all of these parameters in an audio mixer, it capture the entire state, and then you can actually transition between these states in the game while the game is running. You can transition between these states in weird and wonderful ways, and it really allows these audio mixers to change like the theme or the mood of the running game as you're playing it. So as an example, I'm sitting in a cave and I want it to be really dark and moody. Step out into a field. I want the mix to come up. I want music to start playing. This is an example of like mood transitions that you can do with snapshots. And entire sections of the whole soundscape can be brought in. It can be combined with features that I'm going to show in a minute to really change the entire mix of the running game. And you can you can bring in and out effects, and you can change the wet mixes of those. And I'll give an example of that in a second. But firstly, I want to show another example of snapshots. And I've got a situation here where I'm playing both the music and the ambiences at the same time. But I don't actually want that. What I want is I want to play, as an example, I want to play music while I'm running around, so it's like action. And then I want to play just the ambience while I'm standing there, like boring, just standing around, just play the ambience, and then back into running, back into music. So that's pretty simple. But yeah, so all you have to do is create another snapshot. We'll call this one moving. And we'll call another one static. And the two snapshots here, I can go straight into the game and start setting up these snapshots, setting up the different moods or the themes. I'll do that now. Okay, so I've set up the two snapshots, and then I simply have to go and hook it up to the game logic. And I have an example here that I've already set up, which is basically just a snapshot switcher script. And that's essentially going to just change based on whether we're running or standing. And I can show you that code. It's really simple. This is the switching code. It goes from the first state into the second state based on whether you're running or not. And that's implemented here in this first-person character script. And it kind of just says, you know, if we're moving, transition to the first state. If we're not moving, then transition to the second state. Really, really simple. But when you combine it with the mixer and all it can do and snapshots, it becomes really powerful. So I'll show you how that works. So I just need to set this guy up. So I'm going to drag this guy onto here. And I'm going to say my first state is moving. Second state is static. And I want to do that over 1.5 seconds. So now I should be able to jump into the game. And move. Okay, so it's a weird example, but it shows you what you can do with snapshots. Cool. So we also have this this concept of exposed parameters, and what exposed parameters are is allows you to really step in and tweak some really fine-grained aspects of your audio mixer. You can expose individual effect parameters. So I'm exposing the decay here of an echo effect in one of the audio groups. And once it's exposed and I give it a name, I can modify these guys directly via game logic. So I can just step in and say, I want to set this value to whatever. And it really, really allows you to do extremely fine-grained tweaking of the mix. So instead of having to deal with all of the parameters in the mixer all at once, you can just expose the ones you want to tweak in the game, and then access those directly really easily. And I have an example of how easy that is. We just have a situation here where we get the mixer, and then we set float, pass it a name, and set the value. Really simple. So we also have a concept of sends and returns in an audio mixer. And if any of you guys are audio guys, you'll know what a send and return is. And but I'll explain a little bit what a send and return is. It allows you to send like portions of the signal from one area of an audio mixer to another. So if I have signal that I'm having over here in this part of the mixer, in this part of the hierarchy, I can actually send that signal directly to somewhere else, anywhere in the mix, in between individual effects, in an audio group, for example. As an example, I may want to split the signal at some point in an audio group before some certain effects are applied. I want to apply some different effects, and then I want to mix the whole thing back together with the original signal. And this is really, really powerful stuff that you can combine with snapshots to like change the entire like soundscape, because you can actually snapshot the send level of sends and returns. And what a send level is actually like how much of the signal you are sending to the return. So I'm going to give a quick example. In my example, we're going to have a look at the ambience, and we know that frogs live in like dark cave areas, I guess. So we want to add a little bit of reverb to the frog. So I'm just going to, for no particular reason, I'm going to add a new group, and I'm going to call it reverb. And I'm going to add a send. I'm going to add a return to this reverb. I'm going to put it above the attenuation for now. And I'm going to add a send to the frogs. And I just simply add a point that sends to the reverb's return, push the send level up, and then we need to actually add the reverb effect to this audio group, as an example. And now we should be able to jump in and start tweaking the reverb levels. As you can see, the frogs is actually sending part of its signal to the reverb, and you can see that in the metering. And I'm just going to tweak the reverb. Alright, cool. So that's an example of send and returns. And yeah, super simple. Now, I just want to quickly talk about ducking and what ducking is. And essentially ducking is a feature that we have in Unity, and it allows you to basically lower or compress as well the one part of the mix based on something that's happening in another part of the mix. If I can give an example of what that is, like you have, for example, a first-person shooter when you're running around and you're shooting, there's a lot of gunfire, there's a lot of explosions, and there's a lot of stuff going on. But you want to be able to hear what this NPC over here is talking to you. Usually, if you just played the NPC talking while there's an explosion going off, you wouldn't be able to hear it, right? So what ducking allows you to do is it allows you to dynamically, without any code from you, basically, as soon as the NPC is talking, we reduce the volume. It's analysed that the NPC is talking, and we reduce the volume of every other sound in the mix, as you can see here. This is how you would set it up, and this shows you the level at which we're ducking the signal. And it's also known as, in some areas, as a type of side chain compression. And Unity provides this as part of any audio group. You can duck any audio group from any other audio group. And I'm going to give a quick example of this. I've already set up a situation where we're ducking this main group, and we're ducking this based on the SFX group over here. And we're ducking based on measuring the level of the signal coming through. There's other types of analysis you can do, but I won't go into those just yet. And I'm ducking by a certain amount, and I'm going to have a 1.5 second release time. So the SFX reverb over here, and the situation that we're going to be sort of demoing, is the example of a grenade. So when a grenade explodes, you want to play like a tinnitus ringing effect, and you want to bring down the mix of everything else, because you only, like when this happens, percussion, you only hear this ringing, and then we want it to sort of fade away and release out again. So I've already set this up, so I can just jump into the game and give an example. I'm going to play some music, run around, and then drop some grenades, and show you how the levels are automatically ducked. So that's an example of like setting up a really cool effect, audio effect, without actually having to do any scripting or anything like that. You just set it up in the editor and activate it in code. You don't need any code to activate it. Yeah, so that's my brief talk about audio mixers and everything you can do in an audio mixer, and where we're going with audio in Unity. So I wanted to say thank you very much. Really appreciate it. And I guess I can take maybe one question if I have any time left. If you guys have any questions to ask, that'd be great. Or I'll be also just hanging around here for a little bit as well if you want to talk. So thank you very much.